So let's start out with Dana, I think is our first speaker this morning. He will just talk about, to catch up everybody, many of you maybe are not plugin writers or something like that. So I think that we will have a quick overview of that, but then also a little bit of a roadmap where we are going. I mean, it's amazing the filter interface, how old it is, and it hasn't really changed dramatically, which is a good thing, but that doesn't mean that it's perfect. And okay, over to Dana.
All right. Hi, I'm Dana Robinson. I'm the Director of Software Engineering at the HDF Group. I have two talks actually, because I have 40 minutes, and they wanted me to talk about the state of HDF5 and compression. Both have quite a few slides, so I'll go through them quickly. I'll skip some stuff, I think. But yeah, so I'll talk about our product status, talk about what we're doing on the side of community engagement, and I'll talk a little bit about some of our future plans. So this is our release schedule. This is updated on GitHub. We've got it on the README. So you can see here we have, okay. So we retired 1.8 earlier. We are about to retire 1.10, and we are also going to retire 1.12. And that is actually probably going to release a little bit early. And then we have our 1.14 releases. Oh. Well, people can see, I think, at home on this one. So our latest release is 1.14.2. That includes in-place type conversion. Selection I/O is enabled by default with the MPIO VFD. We've made some improvements to the read-only S3 VFD. It supports temporary security tokens, for example, and then a lot of bug and CVE fixes. So in this release, there's only one CVE issue remaining. I'll talk about CVE issues in a sec. 1.14.3 will release in October. We're getting that ready now. That will be CVE free. We've fixed all the CVE issues in there, with one exception. There's one that shows up for some reason if we build with static turned on. We'll fix that too. This is going to be incorporated into the last E4S release for the exascale computing project. And the focus will be addressing on any remaining ECP-related issues, a lot of parallel fixes and some cleanup and stuff like that. Then for a 1.14.4 release, I've got it tentatively listed as being in the spring of next year. So we plan on having 2 1.14 releases per year, unless something else really drives it. As I said, the 1.8 line ended in January, the 1.10 line will end now, and the 1.12 line will end probably right after 1.10. I have it listed on here as in November, but we're going to try to release that as soon as we can. Now that we have the CVE fixes in 1.14, we're just pushing those out to 1.10 and 1.12, and we'll move those down. So just as a quick review, we've talked about this at other hogs. The major 1.14.0 features that came out with that major release were subfiling, multi-data set I/O, selection I/O, and the onion VFD. Subfiling is basically kind of lets you do that middle ground between file per process and one single shared file. Multi-data set I/O lets you stripe your I/O across multiple data sets. Selection I/O lets you pass selections to virtual file drivers instead of doing a whole bunch of small I/Os. And then the onion VFD allows you to basically version operations on the file. And then VFD Swimmer, we were hoping to get that out. That is still TBD. We're trying to find some funds to get that finished up. So the HDF4 release schedule, I'm going to skip over this since I don't think anybody here is really an HDF4 user. But one thing that I will point out here is that we actually do maintain HDF4. We've been maintaining this for 30 years. So when we're talking about plugin provenance and like keeping an eye on things and making sure that stuff still works for the long haul, we've been working on HDF4 since I was in high school, and I'm 50. So we are doing a good job at keeping track of stuff and making sure that things still work with modern compilers and our usable pieces of software. So I'll skip over all this. And this is like our commits from the last, for our commit history over the past couple of years. And so you can see, I mean, before 1994, I don't think there's any history at all. This is just started here. And then we did a whole bunch of work recently to bring things up to speed. So HDFU, the last release of this was 3.3.2, that was released earlier. That's with 1.14.2 and with HDF4 4.2.16.2. So we no longer maintain versions that are based on like 1.10 or 1.12 or anything like that. We'll just it'll come out every year after the HDF4 release. So the product release schedules are for every product that we have is posted via the README on GitHub. We're trying to minimize the number of versions we support, which is why I'm getting rid of all these older branches that we don't really need to support anymore. Before, we kept 1.10 around or 1.8 around for a long time because of performance reasons. Those have been fixed. A lot of the security stuff has been fixed, so we're just getting rid of the older versions. We'll release HDF4 once per year, HDF5 twice per year, HDFU once per year after the HDF4 releases. And all of the release stuff, as much as possible, we're pushing to GitHub. So that'd be the place to go for everything. As far as community engagement, one of the things that we're working on is we have a dedicated engineer of the week whose job it is to monitor our key products on GitHub. We're going to start monitoring the forum. And so this is just to make sure that we're addressing the community's needs and making sure that we're responsive to people's inquiries. We tag things, we assign them, we get discussed, we make sure that things move through. I hope that you are seeing this if you're looking at how we're working on GitHub. It's been a bit of a transition for us, going from we've always been open source, but we've also grown up in a walled garden just due to the age of the project and how it started. And so for us, it was a big transition to move to GitHub and to be in more public and to accept more pull requests from outside the company. And so we're still working on those processes, but I hope that we're doing a better job of being a better open source community member. So we have the HDF5 working group meeting. The purpose of that is to discuss HDF5 library development. People can talk about RFCs. We go over recent PRs, issues, discussions in GitHub, other technical discussion. It's not really for support, so if you have questions, you should come to the call of the doctor that we have. It's every Thursday at 10 a.m. Central Time, and it's open to anyone. So if you're interested, just want to sit in and listen and hear how the sausage is made, feel free to drop in. Just shoot me an email at the Teams meeting so I can send you a Teams invite. And like I said, everything's moving to GitHub. So releases, bug reports, GitHub issues are moving there. We're going to try to move the existing Jira issues to GitHub, some of them. Not everything needs to move. And we have issues that are in Jira that have private data, so those will not move. But we want to move everything there so that it's all transparent and not hidden in our on-prem Jira system. New feature requests should go to GitHub discussions and not be issues. There we can discuss new features, what's going to go into the next major release of HDF5. Support questions can go to help at HDF Group or the HDF Group forum. I prefer that people create issues on the HDF Group forum, because then that becomes searchable and then everybody can benefit from the answers that you get, kind of like how Stack Overflow works. And then we're going to be moving all the development documentation in the HDF5 working group, meeting notes and things like that into the GitHub wiki. Some things are not that great on GitHub, code review, roadmaps, things like that. So we're still working on how to best present the things that we're doing through GitHub. Code owners, we've been trying to incorporate people from outside the company into the process of creating HDF5. And so we have a code owner from outside the company for HDF5, and we have one person for HDF4. And so if you are interested in participating more in the development of HDF5, please see me. I can talk to you about becoming a code owner. We don't really have a defined set of responsibilities for code owners, but these are just only people who are more into reviewing pull requests and helping us go over code and things like that. So the change management, one of the things that we've had trouble with in the past sometimes is we're very good about things like binary compatibility, about file format compatibility, but there's some more other gray areas where we're not always, it's difficult to know what to do, like things like, so can I drop the auto tools? So that's not really a file format change or anything like that, but that needs to be discussed with the community. And so we need a mechanism to communicate with people about these sorts of things. Or if I change like command line tool options or things like that. So we're implementing a policy for how we handle things like that. And it's going to go through, basically through posts in the forum and discussions on GitHub. And that will be where we seek comment. So we'll create a discussion post on GitHub. We'll create a sticky post in the HDF forum if we're going to make a change. And we'll make an announcement in the newsletter. We'll try to be as noisy as possible about it. I'll bring it up at the working group meetings. I'll try to hassle people that I know might be affected by it, but don't count on that, because I don't always know who's going to experience pain if I change things. And we'll allow at least 30 days for comments. Usually much longer, but at least 30 days before we change things. It's in place in HDF4 and HDF5. We'll move it to other products soon. And so you can see on here, we have like I've created these new things here. There's breaking change and there's proposed change. And so you can add things in there. So future plans. So what are we going to work on in the second half of the year? I mean, the second half of the year is half over, but there's increased work on security. So we've been spending a lot of time trying to fix CV issues. Everybody seems to care a lot more about security now than they did in the past. And another thing is that we're trying to provide the best possible library for the end of the ECP, exascale computing project. And then another thing that I want to work on is that it seems very important that we are better at interacting with the cloud. And so I want to make the read-only SVVFD a first-class citizen, to where we have better testing, to where it's better quality code than it is now. And then we're also going to plan on talking about what we're going to put into HDF5 2.0. People had a lot of ideas at the last hug that we were at. I'll put a lot of that stuff up into the wiki this week, so we can discuss it here. But we would like to identify features of the community that people think are important, and then try to identify resources that we can use to make those things happen. So when it comes to taking security seriously, all CV issues are fixed. We still have covariety and OSS fuzz issues that show up. Most of them are obscure. They're things that happen during like error paths and things like that. And the final releases of 110 and 112 will be CVE free. We've got those ready and they are CVE free now. And we have a thing that you can look at. There's a file inside of every maintenance branch, that shows you which versions of the library are affected by which CVE issues. So if you need to know, that's where you can go look. Or you can test it. There's actually a thing that's in the test suite in the CVE repository that we have, where it's just the CVE test repo. And you can run that over any version of the library. Even if you want to try it with like 1.8 or whatever, it will let you know which CVE issues that you're vulnerable to. So yeah, and we're working on better integration with OSS Fuzz, OpenSSF scorecard, and we're trying to fix the identified issues. So yeah, so there have been about 60 CVE issues. These are the important ones that the US government tends to care about. They're tracked through MITRE.org. And these are the ones that people are always emailing us and asking us when we're going to fix them. And so now the answer is they are all fixed. At least the ones that I know about. The ones where it says up here untested, those are the HDF5 GIF tools. And so for those, we just tell people you can disable the GIF tools if you don't want to have them. We have not actually gone through and fixed those yet. And there's one CVE issue that it says untested here, and it's because there's no reproducer for it, and we've made code changes that we think would fix that, but I don't have enough information from this, what was reported here, to be able to tell if that's fixed. There's no proof of concept file. So yeah, so providing the best HDF5 library for us. We're going to work on integrating more ECP vol connector integration, such as the async vol connector as GitHub Actions. We're trying to fix as many parallel and HPC related JIRA issues as we can. I'd like to link in the HPC CDASH results. It's a reporting system that you can see the results for building on all the supercomputers that we test on right off of our README page. And then we have a virtual object layer test suite that we're finishing up that is part of the library now. And then, of course, better documentation, some internal code cleanup. And then, like I said, the read-only S3 VFD, we want that to become a first-class citizen. So I'd like to expand that to Google, to Azure, investigate performance, look into replacing curl with S3 C library, and a bunch of other things that we'd like to get done. This will not happen in the next 2 months. This is a bigger thing that will happen over the next year, but I'd like to identify some of this work and come up with a plan and so that we can have cloud optimized HDF5 files work even better in the future. And if you haven't seen those presentations by Alexander, you should really go look at those on YouTube if you're interested in using HDF5 in the cloud, because they're excellent. And then as for HDF5 2.0, TBD. So I have my ideas for what I would like to work on, but I'd like to hear back from other people to get a sense of what sorts of resources are available out in the community that I can leverage. Things like, I'd love to fix the Windows Unicode problem, but like only certain people care about Windows. So I need to find people who are going to be interested enough in that to provide resources, to provide help, to provide expertise. Then we have an HDF5 BOF at Supercomputing. That'll be in Denver, Colorado. We have the Wednesday slot from 5:15 to 6:45. So if you're interested, if you're going to be at Supercomputing, please swing by and join us. And that's what I have for this. And so I should probably get started on my next talk. And then we'll do all questions at the end. This year. I'm old, I'm wearing my outside glasses. Let's see here. Slideshow. All right, so plugin community. So I've got to talk about plugins. I'll give a quick overview for filter plugins. I'm not sure who know, I mean, I know we have some experts here. We may have some newer people, so I'll just go really quickly through HDF5 filter plugins. We'll talk a little bit about the existing ecosystem, such as it is, and we'll have a little bit of some conversation starters about building a community. So what is a filter? A filter is just something that transforms your data on a per chunk basis, but it can also transform group names. There's two uses for filters. They do bidirectional arbitrary transformations. A lot of people call them compression filters. It's the most commonly used for, but you could do anything. We have the Fletcher 32 filter that can add checksums to things. You can do whatever you want to the buffer that passes through, as long as you can undo what you did on the way out. Happens early in the I/O pipeline, happens before type conversion, everything else that we do in there. And they can be chained, and the order can have a huge effect. For example, we have a shuffle filter that lets you reorder the bytes. And so if you have small integers, you can use a shuffle filter to reorder all the bytes so that you put all the zeros together, and then those compress great. So the order can hurt you or help you depending on how you set it up. So we have this thing that we've shown in the past. This is our I/O pipeline. Probably needs to be updated a little bit. It's gigantic and complicated, but as you can see, so here's your read call, and this is where you are, right? You're very early on when we try to read the chunk off the disk. So setting a filter is really easy. We have different API calls for the built-in filters, the HDF5, so there's H5P, like set deflate. But in general, you're going to use H5P set filter. It's got a couple of parameters. You'll pass it in like your data set creation property list. You set the filters at the creation time. They cannot be changed once you assign them. Then there's a filter ID, and we'll talk more about those in a little bit. Don't confuse filter IDs with HIDT library IDs. Those are not the same. And then there's some flags. You can specify whether your filter is optional or mandatory. And then there's a bunch of filter parameters that you can pass in. Filters can only be used you can only filter dataset data and group names. Datasets must be chunked. You can't filter variable length data. The way that variable length data is stored in the library is the dataset actually stores offsets into a global heap, which is not compressed. So when you compress a variable length dataset, all you're doing is compressing a bunch of offsets, which is not going to compress very well. And there's a limit of 32 filters in a pipeline. It's hard-coded. Dynamic filter plugins. Since HDF5 1.8.11, you can use filter plugins to load third-party filters. They're implemented as dynamically loaded shared libraries that use the interface defined in H5PL extern.h. If a plugin with a filter ID is required and it can't be found, the library will check the plugin paths to see if it can find it. There's some defaults, and then there's some API calls that you can use to add plugin paths and manipulate that chain. And filters are searched by IDs. Compression filters, we have that ID that I mentioned before. This one right here, this H5Z filter T, which is just type def to an int. We search by that. That's what we look for. And they can be disabled. There's an API call that you can use to apply a mask, where you can turn off filters, where for security purposes, you decide that you don't want anybody to be able to load a compression filter. You can switch that all off. So inside the library, there is a plugin cache. We have a loaded plugin cache. These are shared through all the plugins that are used, whether it's a VFD, virtual file driver, virtual object layer connector, or a filter. They're all the same as far as the library is concerned. So it will save everything that it's seen. I don't think it ever gets rid of them. And then we also have a set of plugin search paths. And again, these are used for absolutely everything. So we decided to not split them up because we didn't think people would have so many filters that would become a problem, a performance bottleneck. So we just have the one. It could be split if we needed to. There's a bunch of H5PL API calls that you can use to manipulate this. There's H5PL append, prepend, replace, insert, remove, get size. That just tells you how many filters there are. And so you can actually go through and look at the list of plugin paths and reorder them as you see fit. So building a filter, this is not intended to be a tutorial, but I just wanted to show you that this is not a lot of work, that the code, if you go look in the plugin repositories, when we talk about maintaining plugin filter plugin code, it's not a lot of code in general. Some filters are maybe do more complicated stuff under the hood. Those could be larger, but in general, most filters are quite simple. So there's an H5PL extern.h that identifies the plugin interface, so you have to implement that. And then there's H5Z develop.h, which includes a bunch of stuff that you're going to need to implement to be a compression filter specifically. So you basically implement these two API calls that we have here to basically get the type and get the information that we're going to query to see, is this a filter plugin, and then set it up. And then you just basically fill out the H5Z class 2 struct and implement your filter function. There's just a couple of callbacks that are in there, so it's actually quite simple. And there's just one filter function. We have a flag that tells you if you're going in the compression or the decompression order. And so it's actually quite easy, and you'll see that most of the filters really don't have a whole lot of code in them. One thing that I do want to mention since we're here is there's this memory issue that we've had with filter plugins in the past. It's a little better now because we got rid of this. We had this memory access, this memory sanity check feature that we had, and the problem was that added canaries. And so as you reallocated memory, then you would lose the canaries, and then the library would get mad at you and assert and stuff. So so that's been removed. Now we just rely on fsanitize equals address in Valgrind to find those issues for us. But the problem is that if your memory allocate, the filter can reallocate memory. It can free and create new memory or reallocate. And so if your filter is linked to a different memory allocator than the library is, you can wind up with problems. And you see this most commonly with Windows, because you're going to have a debug C runtime, and you'll have a release runtime. And so if you have a release library and you're creating your filter plugin with the debug library, those do not share state. The C runtime is a bolt-on in Microsoft, and so that's a problem. But you also see this if you're using a debug CRT event, or a debug memory allocator of any type. So, but it's less of a problem now. Microsoft has changed their way that they deal with the CRTs now, I think, so to the point where you don't have to worry as much about which version of Visual Studio is used to build something. So where are filters stored in the file? Well, filters are stored in HDF5 metadata. They're stored in object header messages. And I put 2 on here so you can kind of see that we do store these things as a part of the file format. So some things are not as easy to change because we would have to version the file format. So some stuff is hard-coded in a way that is non-trivial to change. So, and then these object headers are used for things like data sets and groups, and that's how we know that things are compressed. So the existing ecosystem. So we have there's built-in HDF5 filters. They're built with the library, szip and zlib, depending on library availability. Now with libac, we build the szip by default the same way that we do zlib if we can find it. So we have the zlib, we have szip, we have Fletcher 32, we have nbit, scale, offset, and shuffle. Those are the standard ones that we've had for many, many years. But we will not be adding any new filters as built-in filters. Everything will be done in the future as a compression plugin. We have this repository here, the HDF5 plugins repository that Elena mentioned earlier, that was created as a part of that earlier work. And that contains the following filter plugins: got BLOS, got bshuff, bzip2, JPEG, LZ4, LZF, Mathis, ZFP, and ZStandard. And it's fundamentally CMake oriented. The auto tools are not as well supported. The CI doesn't use the auto tools. Has some CI, could use some improvements and better transparency. Some CI badges would be nice. Link it to HDF5 and have some plugin GitHub actions and stuff. And more thorough testing. Right now, I think it just does very simple. You know, could it compress and uncompress a simple data set? But this could possibly be used as the home for future plugin work. This is what we decide is where everything is going to live. And the doc directory does contain that 2014 proposal. So that's there if you want to see what people were thinking back in 2014. It's basically the same thing that we're thinking now. I didn't even notice it until I was done with this talk, basically. And I was like, oh, this is exactly what I was going to write in the next section. So, so I'm glad that everybody had the same ideas back then. So filters can be registered with the HDF group. If you just email the help@hdfgroup.org, we'll send you an ID for your filter. There's some ranges on it, right? The predefined filters for library 0 to 255. 256 to 511 is for testing. So if you're creating your own filter, you can just use those numbers and you won't get any clash with anything that's existing. And then 512 to 32K is for third-party plugins. Those are the numbers that we'll give to you. And then the 32K and up is for if you want to use your own internal stuff, because we guarantee that nothing that is created third-party will clash with that. If you want to see a list of it, there's a list online of the registered plugins. We're probably going to move this soon, right? We're trying to retire the portal, and this really should live, you know, probably someplace like the compression library, not on our some other documentation. But the registration is just about filter ID management. We don't make any guarantees about quality or anything like that. So it's really just about number management. So building a community. So we're here not to lay down the law and tell you guys how compression filters will be managed in the future. This really, we wanted to make this to be a collective thing that it's useful for everybody. And everything that follows is just to get the conversation started. These are just things that I've thought about, that we've discussed internally, that we think are things to consider. And then there's these 2 afternoon sessions. We have one today, I think, that we can use for talking about how we would maintain all this. So what is needed? I think we're going to need, there's going to be a canonical location from which to obtain filter plugins. If people want to create their own stuff, that's fine. But I think that as an organization, we need one place that becomes one-stop shopping for filter plugins, especially if we're going to try to distribute this to other places like Anaconda and things like that. I think we need some standards that a plugin must meet to be considered for inclusion in our repository of filters. And then we need a mechanism for the maintenance of and upkeep of these plugins. So a canonical location could be the existing one that we have. We could start a new thing. It could live under different organizations. We could start a new organization to hold it. Do we want to build pre-built binaries? Remember, now we do. Is CMake okay? Do we need the auto tools? Do we need to support both build systems? I don't know. Who maintains the code? We need to decide who's going to be responsible for updating the infrastructure, fixing things when there's problems. And then how do we distribute the filters? How do we need to notify things like Anaconda, different Linux distributions, things like that? And then should they be distributed with the default build library? Right now, the HDF5 plugins are distributed with the binaries that we create. Do we want to continue to do that? So then for standards, platform support, doesn't matter if Windows isn't supported. Do we want to mandate that everything's supported? Filters that require specific hardware, like if it required a GPU, do we, is that okay? I mean, if you want to have a set of filters, if the idea is that like you should be able to get your data back out of something, should you have to require that it be buildable widely, or can it be, are we going to allow very special purpose filters? Again, build files, CMake, auto tools, testing, we have a common test suite that's in there. Do we need to expand that? Are there special cases that we need to consider? Code quality, do we want to make sure that like things pass via with fsanitize equals address, coverity, warning-free builds, code spell? These are all things that we can set up. Clank format, are we going to demand a particular style, or is it just the Wild West? Documentation, what are the requirement amount of documentation? Basics, you just have to have CD value documentation for the different filter parameters. So something more that we need. And then security, do we need to do anything about security? I mean, a filter can execute arbitrary code. So what does it mean if somebody's going to be pulling in stuff out of this to be used? Do we need to have like code signing? I mean, I hate to say that word because I know that's a huge problem for us when we try to sign things for like HDFU, but is that something that we need to consider? Because everybody seems to be taking security very, very, very seriously now. Maintenance, who fixes problems? Is it us? Is it the organization farms that out? Who's going to review pull requests? And what happens when a filter maintainer disappears? What happens when the underlying libraries are no longer maintained? What are we going to do? What's going to be? How are we going to deal with this in the library? And then what happens when the filter API changes? So if we change the H5Z interface so that we're going to, for example, better support like heterogeneous computing, who's going to go through and update all the filter plugins? Some of which may not have authors that are active anymore. So, and then who pays for all this? These are all questions I think that we need to kind of work on and figure out in this community. And who makes up this community? How often do we need to meet? Do we need to meet in person, maybe as a part of the hug? And then one of the things that's come up, I think it was even brought up at the Ohio hug, was it'd be nice to create a test suite that will try and store your data and then give you a bunch of metrics on like how well things worked in compression speed, on compression ratios. And so that would be a useful thing, I think, to have, is that people often wonder, like, what is the best method for my data? And then also, too, we could use that as a data point to make sure that we're not doing anything unfortunate in the library. So that's what I got. Again, the hug. And yeah, support our nonprofit mission, because we have to keep the lights on and be able to keep this stuff running. So if you have ideas for funding, if there are things that you want to work on with us, please let us know.
Okay. Good. Okay. Do we have any questions?
I just want to comment. I don't remember if it was mentioned at HUG at Ohio. There is a test environment from Argonne Lab where you can drop and they will generate, drop your file and generate even PDF report. Oh. And I don't think it is noted. If we need to find a link, I can find. I have it somewhere.
Would it work with, if we had a big suite of compression plugins, would it work with that? Okay. That'd be really handy. I think people often have that question, is what is the best way to, oh.
Yes, it's early morning.
Yeah,
People have
people need more coffee.
haven't had
Yeah, hi. Thanks for the talk, and yeah, I'm very happy to see that you're looking into organizing the plugin community, as you say, and I think that's very valuable. I don't have particular question now. I think it would be good to discuss, but when we have time.
Just a curiosity question. So if I understood it correctly, the compressor sees it at like the byte level. Does it know what data type? Like, is it 64-bit, 32-bit, integer, floating point, and so on? Or it just has to
No, it's
try
just
its
a
best?
buffer. That's the only thing that you really, yeah, I don't think there's, H5 struct has the data type in it. I think they're just like, they're agnostic. I think it's just a buffer. Yeah, yeah.
Hello, hello, can you hear me?
Yes.
Okay, so this is Francesc Caldet from the BLOS development team. Thanks for your presentation, Dana. I have a couple of questions. One is quite technical. I am interested in why you are thinking in changing from the curl library to the S3C library. What does buys you the S3C library? And the second one is more like organizational. So in the BLOS team, we already paid a lot of thought on things like dynamic plugins and how to distribute these dynamic plugins to the community. So we already converged on using Python wheels for doing that. It seems like a strange choosing, but we decided to do that because, well, I am going to explain that on my talk. But for sure, we have a lot of points where we can exchange experience, and yeah, I would love to have like a conversation with you guys on the decisions that you are thinking for, especially for distributing filters on binary forms. Okay, thank you.
I look forward to hearing your thoughts on this. I don't have any specific thoughts myself on exactly what would be the best way of doing. I have nebulous thoughts, but I don't think I have like good concrete plans for distributing filters right now. But as far as the read-only S3 VFD, I mean, that's just the way that if you want to use the C library, which is embedded into a great many things to talk to the cloud and look at HDF5 files that have been uploaded to the cloud, then that is the way to go. And so Alexander has had a couple of really good talks recently where he has shown that you can get very good performance from doing that if you set your files up to in a certain way, that they're basically page aggregated and use chunk sizes that are reasonable size. You just want to minimize I/O.
Excellent, thank you.
The question was about why the switch potentially from libcurl to the native.
Oh, yeah, I'd like to see if that is more efficient or not, or if it's, I mean, it might be that libcurl is a little easier to adapt to other things rather than having like 3 different C API versions of the library, or the VFD. But I just don't know. It's something I would like to just look at to see if that helps at all. There's not a lot of code in the S3 VFD, so I think it should be pretty easy to experiment with.
Okay, thank you.
Other questions? Let's see. Got about 4 minutes.
Yeah, just to answer the previous question, some filters use the data types like to do shuffling, so they need to get this information, or some filters they use the dimension like ZFP to take blocks in each of the dimensions. So they need information more than just the payload of the data, and they retrieve it from the HDF5 API as it is now.
Since we have time, maybe a little bit of a wild question from someone who is fairly new here. Since you have now all these filters that touch the data on a byte level, my question is, so is there any use case to also do encryption?
You could, and people could create an encrypted filter. But the problem with that is that you're only encrypting the raw data. So the metadata that's in the file is still visible to everyone. So maybe that's fine for you, but if there's important information in there, like, you know, if there's the structure of the file and things like that,
I would encrypt the entire file,
then
of
people
course.
might be able to gain information from that. So
There is if you're interested, there is actually a GitHub repo out there that I forgot which AES 256, or if you're interested, I can send you the link. So people have done that, and that is a use case. And in sort of earlier versions of the file format, before sort of everything got shoved down the global heap, you could actually encode the metadata as well.
yeah, that's another limitation, is that since variable length data is not compressed, it cannot be encrypted like that. But also, I mean, just if you're looking at medical records and there are medical tests, if the metadata says that, you know, this data set is, you know, a particular type of, you know, imaging study or something like that, you get information from that without even actually seeing whether it was positive or negative. And that may or may not be of interest to somebody, like if you're a politician or a celebrity.
Yeah. There's another.
Yeah, here I will follow up on the question of about encryption. Is there any request of making HDF5 data protected against fraud or change? This means by blockchains, technologies, and such things.
Well, you can do checksumming. So right now, one of the filters, I think I forgot if it was on your list, is Fletcher 32 checksumming, but that would apply to dataset chunks. Again, it doesn't, I mean, the metadata, the HDF internal metadata is checksummed. So if that's corrupt, I mean, some of the CVE
But I would say that if you had an HDF5 file and you just wanted to make sure that it was not changed or something, then I would get a checksum for it and then put that someplace. I mean, I don't think you need blockchain. Nobody needs a distributed, unless you're in a real low trust situation, you don't need a blockchain. You just need a source for storing those checksums to make sure that they're valid.
Thank you.
Okay, 10 o'clock. Thanks for all the questions.